By the end of the 16th century began the scientific revolution. Now, if you look at the scientific revolution, in fact, historians have tried to periodize the scientific revolution into three periods. One is during the time of the Renaissance, the second is the time of the wars of religion, and the third is during the time of the Restoration. Without actually going into the period of the scientific revolution, we will turn our attention to the beginnings of the scientific revolution, which actually started with the Copernican theory of heliocentricity. Now, the Copernican theory of heliocentricity is important primarily because it acted as a catalyst of change.
Inspired by Copernicus, Giordano Bruno wrote a book of infinity, the universe, and the world. In this book, he wrote, "If the Earth was not the center of the universe, and all those stars clearly seen in the night sky were also suns, then there must exist an infinite number of Earths in the universe, inhabited with other beings like ourselves." This idea about the universe was not accepted by the Catholic Church. They organized an inquisition and charged Bruno with heresy.
Now, the church actually came down heavily on the concept of heliocentricity because the concept of heliocentricity actually meant the cutting down of man to size. Now, it is actually also challenging the importance of man in the universe. Man is just a very small part of that huge universe which is actually governed by the sun.
Even a death sentence handed down by the Catholic Church did not change his attitude, as he defiantly told his accusers, "In pronouncing my sentence, your fear is greater than mine in hearing it." The Dominican monk Giordano Bruno was burnt at the stake on February 17, 1600. It was the twilight of the Italian Renaissance. Christianity was drained of its earlier humanism. The great artistic masterpieces of the Southern Renaissance were no longer being created. The Protestant Reformation was nearly a century old, and the Inquisition was in full force. Members of every church tended to make the same error, that since Christ was the central figure in history, then our own earth, the scene of Christ's death and resurrection, ought to be the center of the universe. Yet, in this hostile environment, flowered great minds that dared to defy old beliefs and bring about a paradigm shift in our perception of the universe.
Copernicus, in his turn, had a very profound influence on someone called Galileo Galilei.
Using spyglasses manufactured in Holland, Galileo built a telescope with a magnification factor of 20. With this new tool, he found mountains and craters on the moon. He discovered that the Milky Way was composed of stars. And he also discovered the 4 largest moons of Jupiter. In March 1610, he published his findings in the Starry Messenger. Galileo was a believer in Copernican theory. However, in 1616, Galileo was told by Cardinal Robert Bellarmine to no longer defend the concept that the Earth moves around the Sun. To avoid confrontation with the Church, Galileo gave in. After singing a recantation of the Copernican theory and accepting the Church's claim that the Earth was unmoving, Galileo said, "And yet, it moves." He continued his work on determining longitudes at sea based on positions of Jupiter's satellites. He continued to study falling objects and penned a book on comets called the Essaya, which was published in 1623.
another very significant contribution of Galileo Galilei in the field of science was this, that he developed two new sciences, the sciences of statics and dynamics. Now, these two sciences laid down the laws of motion, very important, and the mathematical theory of the strength of materials. You have another person who plays a very significant role, or whose contribution is very significant in the field of astronomy, and that is Tycho Brahe. Tycho Brahe is actually a Danish scientist, and with the help of the Danish king, he actually built a very important and the first, in fact, scientific institute of the modern world.
While attending the universities of Copenhagen and Leipzig to study law and philosophy, Tycho Brahe became interested in astronomy and spent most of his evening times studying the stars. One of Tycho Brahe's first contributions to astronomy was the detection and eventual correction of several grave errors in the standard astronomical tables. In 1572, he discovered a supernova located in the constellation of Cassiopeia. Eventually, his fame led King Frederick II of Denmark and Norway to make an offer of funding the construction of an astronomical observatory for him to work there. Tycho Brahe did not accept Copernicus's model of the universe. He attempted to combine it with the Ptolemaic model. He proposed that the 5 known planets revolved round the Sun, which, along with those planets, revolved around the Earth each year. Tycho Brahe's theories were incorrect, but the data he collected during his lifetime was far superior to any other data compilation made prior to the invention of the telescope. After Tycho Brahe's death, his assistant, Johannes Kepler, used Brahe's observations to calculate his own 3 laws of planetary motion.
Tycho's observation were further developed by Kepler. Kepler was a Protestant scientist. A very important book of his was the Mysterium Cosmographiam. And he put forward the hypothesis of the elliptical orbits, which shattered the Pythagorean Platonic view of the circular motion of the heavenly bodies.
Johannes Kepler theorized that the Sun emitted a constant force across the planes of a planet's orbit, which diminished with distance. He believed this force pushed the planets around their orbits. In 1596, he published these theories in a treatise called Mysterium Cosmographicum, or Cosmographic Mystery. This was the first written defense of the Copernican model. In this book, geometric calculations have been used extensively to prove the theory. His next major work, entitled Astronomia Nova, or New Astronomy, was published in 1609. In this book, applying mathematical calculations to Tycho Brahe's data, he showed that the planet Mars had an elliptical orbit, with the Sun at one focus. Then, he extrapolated the idea of an elliptical orbit to other planets too. This was the first of Kepler's laws of planetary motion. The second, which also appeared in this work, is called the area rule, which says that a hypothetical line from the Sun to a planet sweeps out equal areas of an ellipse during equal intervals of time. This means that the closer a planet comes to a Sun, the faster it moves.
Galileo and Kepler, we find they were brilliant mathematicians. That is why they could make such near perfect calculations regarding the celestial world.
Kepler's work was later developed into the law of universal gravitation by Sir Isaac Newton. Meanwhile, there was flowering of revolutionary ideas in other fields too.
A very important figure or mathematician, you can say, during this time was Vieta. Vieta, he developed two branches of mathematics. One was algebra, the other was trigonometry. And this speeded up calculations, which of course will have, which had an utilitarian value, which we will discuss later. Another important figure of this time was Simon Stevin. Simon Stevin, he introduced in 1568 the decimal system. Very, very important. And he provided the essential basis for a whole new science, which was called hydrostatics. He was also the founder of hydraulics. You have Napier introducing logarithms, and Leonardo da Vinci, known for something else, was actually someone who was the founder of scientific engineering. In 1600, we have William Gilbert, who was the physician of Queen Elizabeth and also the president of the Royal College of Physicians, and he published something which is called De Magnete. It was a book which gave everything that one, all the known facts about magnetism. He concluded that the earth was a magnet. Very important, and it was the magnetic force that actually held the celestial bodies in their places. Nothing got to do with divinity. Challenging these misconceptions, proving by rationality, by observation, by experimentations, how the celestial bodies were held in orbit. We find that his observations helped the work of Hartmann and in turn influenced someone called Robert Norman, very important, who was a mariner and a compass maker. Compass is very important because this was the time where you have the geographical discoveries, the desire to find new sea routes, specifically to the world of spices, that is the Orient. Gilbert's physical and non-mythical explanation of the universe later helped Newton. We will do that, come to that a little later. We also have Paracelsus, his developments or his contribution in the field of medicine, and we have Paracelsus actually challenging the established texts of Galen and the established texts of Hippocrates, and Paracelsus was someone who initiated the development of medicine, which was later taken up by people like Harvey. William Harvey is important because he was the first to find out that blood circulated in the body.
In 1628, William Harvey published his work, An Anatomical Exercise on the Motion of the Heart and Blood in Animals. Here, based on scientific methodology, he argued that blood was pumped around the body by the heart and recirculated in a closed system. This clashed with the accepted model of Galen, according to which venous blood originated in the liver and arterial blood in the heart. The blood flowed from those organs to all parts of the body where it was consumed. Harvey had based most of his conclusions on careful observations recorded during controlled experiments on various animals. He was the first person to study biology quantitatively.
In fact, his work reached his fruition under someone called Malfigé, who, with the help of the microscope, showed the flow of blood. That blood flowed. This was something which was shown by Malfigé with the help of the microscope. Harvey's discovery had the same impact in the field of medicine as we find Copernicus and Galileo Galilei's invention in the field of astronomy. Now, it was just as the sun was the center of the universe, Harvey proved that the heart was the center of the human body. It was the controlling force of the human body. Now, these two great discoveries, that is the circulation of blood and the fact that the planets moved around the sun, this played a very instrumental role in future scientific developments. Now we will come to the utilitarian aspect of science. And here we must mention the name of two people. One is Francis Bacon of England and the other is, of course, Descartes. Francis Bacon of England was the Lord Chancellor of England. He rejected teleology and he was a multifaceted personality. He was so many things. He was a lawyer, a philosopher, a politician, a moralist, a scientist who influenced the 17th century thought, specifically scientific, not only scientific thought, the whole thought process of the 17th century was influenced by this man called Francis Bacon. His very famous book was called the Novum Organum. It's called the Novum Organum, and he expounded the scientific method of experiment and observation. The importance that was laid to the something which was started during the time of the Renaissance. It actually is now being propagated by someone called Francis Bacon in England. He lays stress on the value of experiments and observations. He is the proponent of what is called inductive science, people who are called armchair scientists. He also believed that scientific knowledge should be put into use. It should have a utilitarian value. It should not only be, a knowledge which is something which was discussed among the literati. It was discussed among the intellectuals. It was not something which actually needed to be kept in bookshelves. It had to have a utilitarian value. So he emphasized the practical aspect of this movement. He was a strong advocate of organized and collective research and one of the founder members of the Royal Society in 1662.
René Descartes had written in his Discourses on Method, "I am thinking, therefore I exist." Descartes was arguably the first major philosopher in the modern era to make a serious effort to defeat skepticism. His views about knowledge and certainty, as well as his views about the relationship between mind and body, have been very influential over the last 3 centuries.
He set up an argument about the material world in a strictly quantitative and geometric manner. He looked upon the human body as a machine. He was the first to formulate the philosophy of dualism, that the dualism between the physical aspect of man and the soul, the duality between the body and the soul. And in fact, he laid the foundation of the Cartesian dualism, and this was actually a logical conclusion. Cartesian dualism was a logical conclusion of Descartes' reduction of the sensory experience first to mechanics and then to geometry. A further step was to divide the world into two. Just as the body had 2 aspects, there was the body, just as a human being had 2 aspects, the body and the soul, the earth too, or the universe too, had a dual aspect. Dualism could be applied here also. It was the physical aspect and there was another aspect which was moral. Science lay in the realm of the physical aspect. It was measurable. Where the moral aspect is concerned, this was outside the purview of science. It was in the realm of revelation. So by doing this, by introducing dualism in the concept of the universe and bringing about, and sort of dividing it into 2. One in the realm of physicality, the other in the realm of morality. What was he doing? He actually freed the scientist from his moral obligations. So the scientist's realm was the physical aspect of the universe, not the moral aspect of the universe. That was in the realm of revelation. It's very important as far as the evolution of scientific knowledge is concerned. Now we find that Bacon and Descartes together spoke about the experimental basis of science, the importance of experiments to prove a certain point. Now, and this philosophy had a profound impact on the virtuosi. Who were the virtuosi? The virtuosi were the middle class, the learned people. Not only did it have the theory of experiments have an impact on the virtuosi, it also had an impact on men who were actually involved with very, very important technical crafts, very high technical crafts, such as the surveyors, the metallurgists, the military engineers, the clockmakers, the makers of chronometers, the industrial chemists, instrument makers. They also were influenced by the experiments. Why? Because these experiments would go a long way in developing their art.
Descartes was convinced that science and mathematics could be used to explain everything in nature. He was the first to describe the physical universe in terms of matter and motion. He saw the universe as a giant, mathematically designed engine.
In the 16th century, we find these craftsmen wrote books. Whatever knowledge they gathered from their experiments, they published it in journals like the Philosophical Transaction, which was brought out by the Royal Academy from 1664 onwards. There were also certain individual members of the bourgeoisie, even churchmen, who actually played a very significant role in the propagation of science during this time. Now, one must mention what Boyle did, the contribution of Robert Boyle, a Puritan, to science. And we find that he discovered the vacuum and the gas laws, and from this was developed the steam engine of the 18th century. The interesting use of coal as a fuel. Why? Because timber was getting scarce. And if you had to use coal, then you needed to use the vacuum pump to extract coal from the mines. You have the contribution of another great who was called Rupert Hooke. He was a contemporary of Boyle. He was someone who discovered what was called the Hooke's law, and he studied elasticity. His works on elasticity eventually came to be known as Hooke's law. What are the other important contributions of this man? He invented the balance wheel, which is very important to make very accurate watches and chronometers, which in turn is very important for geographical discoveries, which in turn is very important because they actually made the concept of time very important, and this concept of time went a long way in business transactions and commercial transactions. He wrote the Micrographia, very important, the first systematic account of the microscopic world, including the discovery of cells.
Robert Hooke's handcrafted leather and gold microscope is on display at the National Museum of Health and Medicine in Washington, D.C. Through this microscope, he discovered a world not visible to the naked eye. He coined the term cell to describe the basic unit of life. The cells of a cross-section of cork, when seen through the microscope, resemble the cells where monks lived in a monastery.
His greatest contribution was the idea of the inverse square law and universal gravity. He is said to have influenced Newton, where you talk about Newton's universal law of gravity.
এই বৈজ্ঞানিক আবিষ্কারগুলো শিল্পের অগ্রগতির ক্ষেত্রে কতটা সাহায্য করছে?
It does help in industry. If you look at, as we have just said, now if you look at the extraction of coal from the coal mines, the coal will become the next important fuel before, of course, steam is discovered. But the discovery of coal is a very important infrastructural development because coal gives the fuel which timber used to give so long is now being got from coal. You get another example. You get say, the development of watches, accurate chronometers, the development of the compass, the development of the extraction of metals, the development in the field of chemistry, iron smelting, the smelting of other metals, these all help in industrial development. These all help in the process of industrial development. If you look at the case of England, if you see that the woolen industry became very important in England at one point of time, and the shearing of wool, how was that done? Mechanically. And the mechanics of wool shearing was something which was developed by scientists. So the fact the science was actually after some time having a utilitarian value, it was actually helping the masses, will become evident, and which actually results in the Industrial Revolution later. This is a process which started in the 16th century, continued through the 17th century, and eventually when you come to the 18th century, you have the famous Industrial Revolution starting in England and later, of course, spreading to what is called continental Europe.
Giordano Bruno conceptualized a universe of infinite expanse. Galileo Galilei spent many a sleepless night discovering and recording blemishes in heavenly bodies. Tycho Brahe was reluctant to give up humankind's privileged position at the center of the universe, but he drew up accurate charts of motions of heavenly bodies. Using these charts, Johannes Kepler calculated the trajectories of planets, not perfect circles, but flattened ellipses with the sun at one focus. William Harvey recognized the heart to be the crucial organ pumping blood in the arteries. Robert Boyle deduced that the colorless, odorless, almost weightless air consisted of randomly moving molecules bumping into each other. Rupert Hooke peered through the microscope to discover whole new patterns of nature not visible to the naked eye. The genius of each of these stalwarts of the scientific revolution touched and transformed diverse areas of science. They enhanced our vision, expanded our horizon, radically changed our ideas of ourselves and our world, and also improved the material well-being of our worldly lives.